Hello everyone, welcome to my project presentation. I am Aditya R from Department of Artificial Intelligence and Machine Learning at Savita Engineering College. So today I am excited to walk through my mini project, the AI Assistive Object Detection System for the Visually Impaired. So we all know that navigating a busy street is challenging, but for a visually impaired individual, it can be more dangerous it can be more dangerous. So, what they do is they take up traditional aids like white cans or guide dogs, so which are helpful for them for navigation purpose. But they too have a limitations. They can't tell you what is in front of you and how it is away from you exactly. So that is the gap I aim to fill. So this project isn't about just a code, it's about using AI in a real-time situational awareness and safety monitoring. So the statement of the problem. So let's look at the specific problem we are solving. So visually impaired users often struggle to identify hazards like moving vehicles, traffic lights in real time, and currently there are no widespread system that offer simultaneous obstacle detection and automatic incident recording. Scope of the project. So the scope of the project is a threefold where we detect objects in the real time using a mobile camera using a IP webcam app, and then um, we used distance estimation formula and provided audio warnings when things get too close, and then a video buffering system which we created a rolling buffer that always keeps the last 1 minute footage, which is crucial if an accident occurs and evidence is needed. So this can be increased to almost 30 minutes to 1 hour depending upon the situation, or if we are going to scale this product. So methodologies. So now let's get into the technical side, that is the brain of the system. So we are using a few key algorithms to make this work. First and foremost is YOLO. We used you only look up once model. So where we are using Ultralytics YOLO model because it is incredibly fast performing, bounding the box prediction and class identification. So telling us if an object is a person, a car, or an animal. So with the help of this, I also created my own data set. That is, I took photos of these persons, uh, street lights, vehicles in my person, and then personally, and then I have trained it and annotated it, and I have trained the model. And with the help of this YOLO model, I just fine tuned it, and I just got it in my own way. So for the distance estimation, we didn't use any expensive LIDR sensor. So instead, we used pixel width formula. So the pixel width formula is used for the comparing the pixels of pixel width of the object detected to the reference ratio. So which can be mathematically the approximate distance that is shown from the user. So we also have implemented the optical flow stabilization. So using the Lucas-Kennedy method. So since the camera, that is a phone, might be shaking in the user's hand, this algorithm helps to stabilize the video frames to ensure the deduction remains accurate. So finally, we use multi-threading system. So we use multi-threading system in the case of multitasking. So whenever the video is on, it also needs to send audio messages and have to take a video buffering system. So what the multi-threading is doing is it will allow multiple tasks to do at a simultaneous time, and it allows the system to speak alerts like a vehicle is 3 meters away, so without freezing the videos. So this is the architecture diagram flow where this is the Android, that is the IP webcam app is being connected to the project, that is using the IP address, and then the IP video stream occurs. On the left side the pre-processing of the model is done. That is, we are extracting each frames, and we are converting and resizing the frames. So after resizing the frames, it goes to the object detection model, where it boundary boxes each and every objects with a name, and then the distance is estimated. So using the distance, whenever the object is when the object is approaching 3 meters inside your boundary, then it gives a voice alert system like 3 meters away. So this is what it will give. And in the right side of the IP video stream, it gives a temporary video buffer where it gives rolling 1 minute storage. So the storage can be increased if it is going to be made as a product, or if you are going to scale up it, and the recorded video will be saved. So we don't have specific memory for this, as this is a buffer memory. It requires very low space. It requires very slow space. And then taking look at the design. So here is the use case diagram. So you can see here the user is interacting with the system primarily by listening to the audio alerts, and if necessary reviewing saved recordings. So moving to the class diagram. So this shows how is the code structure. So we have a system controller that manages the flow, the YOLO detector that causes data to distance estimated. So if a hazard is found, the alert system triggers the audio. Meanwhile, the video buffer system runs in the background, continuously queuing the saving frames. And these are all the algorithms we have used. So we used a YOLO and distance estimation algorithm, and flow stabilization, and multi-threading, and continuous video recording. So the hardware and software selection that we have made is very simple. So the basic need of any laptop is okay. So we don't need any expensive optional hardwares. So a minimum requirement of laptop with the minimum number of GB and the version is enough. And the software requirement is you should have Python, Ultralytics, that is YOLO model, and OpenCV for video capturing, and NumPy for the distance estimation, and PyTask for PyTTSX3 for text to speech conversion, and threading for multitasking, and WinSound for Windows sound alerts like a buzzer or a beep sound. So the operating system can be Windows 10, 11 or more than that. And the tools we are using is IP webcam. So this is the app where we are going to connect a video through IP, and we have coded this in the VS Code, and any Python package can be managed. So implementation. So let us now go into the implementation task. Let's see how a project works. Let us now go into the implementation part. So this is my code base, that is so object detection model. So we have first imported all the libraries that are needed for this project, like PyTTSX3 for text to speech conversion, for threading, for multitasking, and Q for video buffering storage, the Ultralytics for importing the YOLO model, and CV for camera, enabling the camera, and NumPy time and maths for calculating the distance, and for uh, wind sound for the beep sound or any alert sounds, and OS is needed for the software purpose. And you can see here, so these are all the various classes that we have in a project. So person, car, bicycle, motorcycle. So these are all the common classes that I have taken for my object detection model. So this periodic beep sound is produced after every 10 seconds. So to see that it is correctly running or not. So speak. So what this will do is whenever the alert message is passed to it, it will convert into a speech. So get position. So with the help of this get position, so using the YOLO model, it will just give a bounding box. So with that bounding box, we will get the position using the width of it. So blur person. If a person is blurred, so his vision will be then converted into a frame. So the resize of frame will be taken into this category, and it will be resized, and the blur person is now uh, uh, get a better enhanced pick of it, and then his um, stage will be his distance will be calculated. So here I have used YOLO model and GP model.pt. So what this GP model.pt is that this is a model which I personally trained using a specific category of data, that is person, vehicles, and street lights, etc. So I fine tune the data, so it will be more effective and accurate than the normal YOLO models. So using this stream URLs, we will be used to integrate to the IP webcam app. So it will also check for the, so it is the coding part where it will check for the connectivity, and then yeah, detector thread. So this is the detector thread where it will capture the objects, and then it gives the detector and it detects what it is, and then calculate the distance from pixels. So this is what the distance calculation from the person to the object, and it will constantly repeat the distance between the object and the person repeatedly after every 2 or 3 seconds. So let us now take a clip. Okay, so copy path. So let's say that, so this is a normal video. So we are going to feed this video into our project and see what it is happening. So it can be given to a through videos, or we can do it manually, that is through live cameras also. So let us now feed this into this temp file. Yeah, we have mentioned over it. So now what it will do is it will just open the frames and connect to the video, and all the reshape, the color gradient changes, uh, then the all the pre-processing works of the video and the pixel representation will be done here. So okay, so this part fully consists of that. So after the resize is done, so using the color gradient method, it will color each and every pixels, and it will come to an uh, mount that we have set. So the all coding part will be here. So after that, here is the main process where it will send the audio messages to the speak, and then it will give all the required alerts as a message or as a wordings. So this is the capital release. Okay, now let me show you what are all the output I got from it. Okay, we got the output video as
2.5 meters on right.
so you can see that
Person is 2.5 meters on left.
so this is the
Person is 3 meters on right.
for the input that we
Person is 2.5 meters on right. Person is 3.5 meters on forward. Bicycle is 1.5 meters on left. Person is 3.5 meters on forward.
So this is the output I got, and that output video is now in my downloads. So it will keep on changing in the buffer as it is replaced by the new one repeatedly. So this is what my project is, and you can also see here. So this is what the coding part I have already explained it to you, and so this is what the output if we get it through an IP webcam app. So you can see here. So you can see here, so this is the IP webcam app. So we can connect it through this IP address. So this was the object detected and the object distance has been estimated. And these are all the console output I have got. And you can see here, so the 1 minute video will be like this. So the video will be here and it will just capture all the output and it will be saved. And the results are, it will give object detection performance will be better, that is 80% clear, and the distance estimation will not be that much accurate, but it will guess accurately up to 1 to 5 meters approximately. And it gives audio alerts, it has audio alert system and recording system, and overall the system behavior may or may not be a lag of 5 to 10 seconds depending upon the specifications of the devices that you are using. And the conclusion, so the AI assisted object detection for the navigation will be very helpful for the visually impaired persons, so which could help them in the navigation purposes. So we can also integrate this model into a new hardware devices so that it will be far more effective, because only a software part will won't give any much changes, but implementing it with the hardware device completely gives a better or a better vision of the future for this visually impaired. So maybe it will become one of the great idea and will become affordable one for the companies, for the users who are all visually impaired. So yeah, this project successfully integrates the computer vision audio alerting system short term. So despite there are many minor latency and hardware limitations, the solution demonstrates a strong potential as smart assistive tools. So this increases the navigation safety and situational awareness for sure for the visually impaired users. So what are all the future works I am planned to integrate with this project is that, so I am planning to integrate four sensors over a front, left, right and back sensors, that is ultrasonic sensor, to gain the perfect accurate distance measurement. So this four will be connected into a Raspberry Pi. So using the Raspberry Pi, which is called as a mini computer, so this will be effectively communicate with each other. And the traffic light and road sign detection. So so using the lightweight model, so I will maybe plan to integrate the red, green and the signal detection and the zebra crossing and speed bumps, etc. And then advanced accident detection. So I'm planning to insert a vibration sensor, so which will be very helpful for us for the visually impaired. So if they are met with any accidents, so they using the vibration sensor, it will make the video clips to just stop and the video will be saved in the future. So if at all the accident is real and family members who are interested to see how the accident take place, so they can use it through this video clips, as because the vibration sensor gives a message, the video will be completely stopped recording and the recorded video will be safely and the connectivity. So the recorded video will be on. So it's an investigation can be done using it. And the GPS navigation system. So if at all any accident takes place, the software will be built on account of the family members that will impact. So what the system will do is, whenever a vibration sensor gives an message, it will go to software. This software will be managed by the family members of the visual impact also. So whenever there is an accident or something, the vibration sensor knows the location of the visual impact or the user will be on the GPS will be the location will be assigned to the family members and the GPS navigation will be enabled so that the family can come to the place and see what and do what is there. So this is the first I took, and this is my project here. So you see here. So this is the project I took here. So lecture now the software here requirements installation usage system. So if you have any questions, so please leave in the comment section. So thank you everyone for seeing the video.